So, in martial arts, there is this trick of smashing planks of wood or concrete with bare hand. And your task is to learn how to do it. So you start to search for an optimal way. So you tell to yourself, okay, I'm going to try it. You smash it with your hand and it doesn't work. So you think to yourself, okay, I have to apply more power to my hand. So you apply more power to your hand, but it doesn't work either. So you try it for years and years, and after like 5 years, you figure out, okay, it's not about the power I apply to the plank, but it's about the velocity. I can move my hand in the moment of hitting the plank. How you can practice it? You can think about it, you can learn about it, you can read books about it, but in the end, you have to try it. You have to practice it, you have to smash it with your hand. It will hurt like hell, you will suffer like hell, but you have to do it. There is no better way we figured out yet. Some people say martial arts are just a religion. That some people say you have to do it like this, so we need to follow them. Well, you don't. You can try it, you can doubt it, but in the end you find out it's the best way you can do it. Not think, just practice. Okay, let's take another example. You have 10 boxes, 10 small boxes, you can't see what's in them, and you have one coin. The one coin is put into a random box, and you don't know in which it is put. And your task is to find the coin. So you start to search for an optimal way. You can think about it. Well, it's not going to be in the first one, it would be so obvious. It's not going to be in the last one, it would be too obvious. So maybe like 4. So you grab the 4 and it's not there. So you try to think about it more. Okay, what about 7? That's a nice number, but it's not there either. So you find out that the best way is not to think about it, but just take the first one, look at it, it's not there. Okay, take the second one. Is it in there? No, take the third one. And you find out that the velocity is more important than the force you put into it. How you can practice it? Well, you can read about it, you can think about it, but then you realize you just have to practice it. You have to practice opening the boxes, putting them back, taking the other, opening it. And that's the best way we just figured out. There might be an opinion that it's just religion. Well, religious way would be, it's in the box with number 7. And if you believe it hard enough, it will be there. And if it's not there, you weren't believing it hard enough. So it's the best way we can figure out right now. Okay, you might have a question. Shouldn't I talk about tests or something? Okay, let's do it. Let's take an example of designing a software system. You want to design a software system. The best and the fastest you can. So you might think about the optimal way. What is the optimal way? Well, I can take that little class up there, left upper corner, and I will design it the best way I can, and then design the rest of the system. So you really think about it, you design it the best way you can, and you say to yourself, okay, this is the best class I could ever design. And then you start to design the second class. And you will figure out that the first class was designed completely wrong. So you think, oh heavens, I am such a bad programmer, I have to learn more about it, I have to think about it more. But then there is this other approach that says, design one class, the best you can do, but fast enough, and then move to the other one. If by designing the second one, the first one isn't designed properly, you just redesign it. And that's test-driven development, the best way we can design software these days. Velocity is more important than the force you put into it. How you can practice it? Well, you can learn about it, you can read about it, but then you need to do it and practice it with your hands and with your heads to keep the velocity, not the force. You will suffer, it will hurt like hell, but it's the best thing of designing software these days. Some people say it's a religious approach. Well, this Uncle Bob says TDD is the best way we can design software. You can doubt it, you can test if it's correct, and if it's incorrect, you can do it your way, but it's the best thing we have right now. The religious approach would be, it will only work if you put a word holy to every name of the variable and every name of the class, and you have to believe it. And if you don't believe it, if it doesn't work, you weren't believing in it hard enough. So, hello, my name is Standa. I'm software engineer in NetSuite/Oracle for last half a year. You might remember me also from IBA or Bad Finger Games. I created also this Haskell Hero textbook. Does anyone know Haskell Hero? Yeah, one guy. Who likes Haskell Hero? Yeah, thank you. I'm a big fan of Uncle Bob, so you may think I'm just parroting his thoughts. And I'm test-driven development evangelist. I just talk about test-driven development, and that's what I do right now. There is my homepage and my Twitter account if you are interested. So, what is test-driven development? There is this guy called Robert C. Martin, and he came up with 3 rules defining test-driven development. First rule, you are not allowed to write any production code unless it is to make a failing unit test pass. It means, if all tests pass, you can't write any more production code. It means, if new requirement comes to you, and you just say, okay, I need to add an if statement here, you can't add an if statement there when all tests pass. Second rule, you are not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. It means you can't write all the test class and then start writing the production class. We'll see why in a minute. And third rule, you are not allowed to write any more production code than is sufficient to pass the one failing unit test. So if you have one simple unit test, and you know the algorithm you want to write, you can't write the whole algorithm, you just write a part that makes the failing test pass. There is also a 4th rule that was added slightly after that, after those 3, and it is, when the tests get more specific, the code gets more generic. And it says, if you write test that says, call this function with argument 0, and then assert it returns 0, you write a production code that says, okay, if 0, then return 0. If you add test, if you get 1, then return, I don't know, 10. You can't write another if statement to that because it's not the more generic form of the code. Okay, let's take an example. There was a bug in a feature some mean programmer implemented, and you are the one that should fix the bug. You drill down all the code, and you will see something like this. This is the place where it fails, and you need to fix it. So you think to yourself, okay, there is some multiplication there, some R class, some A method, and some arguments. What if I switch the multiplication for addition? Can I do that? And you think to yourself, okay, I can do it. And you do it, and then some other part of the software, completely on the different side of the program, will starting to fail. And you think to yourself, oh heavens, what am I going to do now? So that's the situation you may come in, and I will try to show you how to program this slightly better with test-driven development. So let's see. The original task was that you need to write a function that computes area of a rectangle. So the programmer was like, okay, that's pretty obvious, it's rectangle, so I'm going to put here an R because it's a waste of time to type all the rectangle stuff. And I put here the name of the function A because it's just obvious, it's area of the rectangle, right? And then you then you figure out who wrote this code initially. Yeah, it was you, a month ago, and you don't remember what it's doing. It's just real world. So, let's do it by test-driven development. Rule 1, you can't write production code unless you have a test failing. So we have to write the test first. This is not a failing test, this is just a test of the environment. So there is an empty test that passes, and when I run it, it tells me it passed. Okay, it's just a check of environment. So, then I think about it, and I come up with something like this. I want some class that would be called rectangular calculator, and it would have a method called calculate area with a width and height of the rectangle. And that's it. Compilation failure. I can't write any more of tests. I have to write some production code now. So it says rectangular calculator doesn't exist. What can I do if you have some IDE of latest generation? It is something like this. For example, IntelliJ, when you hit Alt plus return, it will give you this pop-up menu. So you just create a class, rectangular calculator. Here it is. And then the method doesn't exist either. So you do the same thing. And there you go, all tests pass. This is the moment when you want to commit and push to your repository. This is in some kind of shape that it works, and it creates a checkpoint for you. So if you try something that doesn't work out later, you can come back to this checkpoint where everything was fine, everything was green, blue skies everywhere. And I want to apologize. When I prepared this presentation, I thought rectangle was called rectangular. So everywhere where is rectangular, there should be just rectangle. So pretend it's rectangle there, okay? So, what now? I want the calculate area to actually do something meaningful. It means now it doesn't return anything. So I add there, in area, assign a value that returns our new function to this variable. And it doesn't work, it doesn't compile. So I have to move to the left side, where is the production code, and change the void to int. And now I have to return something. So what do I return? What is the most simple value I can return to make the failing test pass?
Null.
Null wouldn't be sufficient because it expects integer.
0, 1, 42.
Okay, there are some clever ideas here. So, you might be very tempted to put there just width asterisk height, because it's obvious. We are programmers. We know how to compute area of the rectangle. But just imagine that it's not area of rectangle, it's some 100 lines algorithm. You know you can write. You wrote it for like 100 times. You know how to write it, and you want to prove yourself that you can write it out of your head for the first try. And that's when you have to say no. I'm going to go with the simplest variant, because I'm a professional. What would you say if you came to a doctor's office and you wanted your birthmark on your face get removed? And the doctor says, okay, sir, listen to me. I read a blog post yesterday that you can throw the knife to the air and then kick it with your foot, and it will smash your face and it will remove the birthmark. Can I try it? What would you say? Fly knife over your face? Of course you say no. But the doctor is pretty confident. He says, well, I tried it 100 times, I can do it. And you still say, no, I don't want flying knives around my head. So it's the same case. You don't throw knife in the air, although you know how to do it. You just put there the simplest variant you can do, and it's 0. Calculate area, return 0. But that's not right. That's not correct solution. Well, it is now. It fairly satisfies the requirements demanded by the test. So what would you do now? Commit push, obviously, because this is the best you can do in this point of time. And you can, or you should, put an assert statement into the test. So it really checks, it returns 0, and it still returns 0. So commit and push and add another test. Non-zero rectangle has non-zero area. You put 2 and 5 to the function, and you expect it returns 10. But it returns 0. Assertion error, or assertion fail. So what do? You may be very tempted to put there the width times height. But no, let's go with the simplest one. Well, this one is a little tricky, because it's not the simplest one. The simplest one in this example would actually be with times height. But imagine the 100 lines algorithm you may put there. So let's do the smallest step. If the width is 0 or height is 0, then return 0. You can imagine it as a corner case. Like, user doesn't pass me any argument, I just return nothing, because it's the optimal way. Otherwise, return 10. Still just constants, and the test pass. Commit push. So to add another test, you may, and you should, rename the test by what it's currently doing. So the second test is now renamed to non-zero rectangle has non-zero area 2 and 5, and underneath is 5 and 8. And if I want to calculate area of a rectangle with dimensions 5 and 8, I want it returns 40. So now is the time that the simplest and most generic form would be return width and height. All tests pass. Now we are pretty confident with the test part. Like, these tests are enough for me to be sure that it works, and I can do some refactoring. So I look at the production code, and I can see there that if the width is 0, then the return statement would return 0. And if the height is 0, then it also returns 0, so I don't need the if statement anymore. So I can get rid of it, And that's the final form. This is how I believe it's properly programmed, this very, very simple example by test-driven development. There might be voices in your head, but now I have more test code than production code. And the reaction for that is, yes, it happens, and it's very usual. It's actually more usual than having more production code than test code. But now I have to take care of the test code, and I didn't have to before. Well, yes, but if you don't have the test code, you can't know that your refactoring changes don't affect the meaning or the functional behavior, thank you, of the code. So this helps you to sleep better in the future, because if you refactor something and the test pass, you can be significantly more sure that it works how it should. Why is it important to have tests? For the first place, tests create documentation. If you have some manual to a library, you can read the manual, but then you just read the code, because that's what we do. We are programmers, we like to read the code. So you just look at the tests and you see how the class should be used or how the method should be used. You have limited brain capacity and limited throughput of context. If you are solving something really big and then someone says, I need to fix this bug really critically and I need it now, you need to put everything you have in your head aside, take the new context, put it to your head, fix the bug, then put it out of your head and put there back what was there initially. And it's very energetically demanding. And it's even more demanding if you have kids and you don't have more than 10 minutes of concentration, because the kids just don't let you work more than 10 minutes on something. You will go faster because you don't have to check your changes manually. How many times you change something on the back end and then you just went to the web form and try to click it and insert the values? Does it work? No? Okay, try to fix it again. Then click it again, insert the values, enter, no, it doesn't work, okay, try it again. And it's a really long cycle. So tests allow you to make the cycle significantly shorter. And you can also refactor faster, as I said. From what I said, maybe you may think test-driven development will make your life more easier. It does not. It makes you more professional. You will go faster, but you can't make any excuses. Because if you don't use tests, you can just tell your boss, well, it doesn't work, but it's just programming, you know, it's a big system and nobody can be sure about it, so it's just a fact of life that it doesn't work, or it took longer than I expected, because programming is hard, you know. If you have tests, you can't say this anymore, because you have a better way to do it, you just didn't follow it. And as Barney Stinson says, with great power comes great responsibility. If you know the How I Met Your Mother show, you know he didn't say power. So, something about my experience with test-driven development. There is this lovely site called Advent of Code, if you know it, or if you know Project Euler. Those are sites with programming tasks. And you can practice test-driven development there, so I do. You can see my progress on my GitHub repository. I'm coding it in Python, and I also have it connected to continuous integration. So after each commit, it runs all the tests. And then if you know Unity game engine, they added support for tests in latest version. So I'm now coding my games in my free time by test-driven development. And it's really hard, it's really suffering sometimes. But it's cool because I can just leave it as it is and then don't work on it for 2 days. And then I remember what I was doing because it was just small improvements here and there. That's what test-driven development allows you to do. What about test-driven development in NetSuite? There are tens of thousands tests because it's a huge system. It takes 10 hours, around 10 hours, to run them all. No Pokemon pun intended. There are unit tests, there are database tests, there are full stack tests. Everything is tested and it's really demanding, I don't know if it's the correct word, to have everything tested. Because there are systems where you can say, okay, I'm going to implement this, but after a year it's just going to be a throwaway software nobody uses anymore. But in NetSuite, it's a software that is with us for, I don't know, 15, 20 years, something like that. And it will be here probably for the next 20 years. So it's important to have it as much flexible as possible. Some people say, I can't write tests because the environment is not ready for it. I have to create mock database and it's really hard and the customer wants it faster and I don't have time for that. In NetSuite, we are ready for that. There is this lovely developer-friendly connection test. You just extend and then you can take this prepared connection and that's it. You can write tests for database this way. How to learn and practice it? My best experience is to have personal projects you care about and you want to have them clean and nice. There are also some coding kata. You can Google what it is. Those are exercises by Uncle Bob and maybe some other people. This event, thank you for being here. You can practice TDD here. And you can practice it in work, but carefully. Because you don't pay musicians to see how they practice or how they play scales and etudes. I don't know how to pronounce it in English. You want to see the best they can do at the stage, and that's the same in work. Your employer wants to see you to do the best you can, and you can practice at home. Okay, people, we've prepared a sweet bot for you, and we believe the best way you can implement it is by TDD, but you can prove us wrong. So code it anyhow you like, and then we can share experiences. How do you do that? So, if you have some questions for test-driven development, not for SweetBot, it will come right after, hit me now, in Czech, in English, whatever.
Kolik tak času průběžně dokážete ztratit na to, když píšete testy? Většinou se říká, že to je 50/50, že jak napíšu testy, tak to stojí o 50% víc času napsat. A když jste takový odborník na to, tak kolik je to podle vás? Je to fakt akurátní, je to 50%?
Okay. For the record, the question is how many times it's great. How many times I spend with writing tests? Well, if I don't write tests, I can't be sure that it works later. So I just spend more time to testing it manually than to test it automatically. Because if you run the tests automatically, it takes you, for example, 1 second in my game project to run it all and to be sure that the game works. But if I need to test it manually, then I need to play the game, click those buttons, and see what it's doing, see what it's doing, and I have to switch the context. I need to put aside the programming and put inside the head the playing. So I play it, and then I have to put aside the playing and put back the programming, and then I code again. So it's hard to say how much time, because it's really write a couple of tests, write a couple of production code, and just iterate between them. So maybe it's harder to write a test, because if you write tests, you also figure out what the API for the class would be. So that's the work you would do otherwise later if you didn't write the test. But then you would be like, okay, I want to rename this. But if I rename it, will it still be functional? I don't know, I'm not sure. And you can't say for sure, so you will break something, you may discover that it's broken like month later, and it's too late. Did I answer your question?
Yes and no, because what you just said that you will break it and you will discover it months later. When I take, for example, Facebook, they have this rule: move fast, break things, and they have a couple of developers who will go after you and fix these bugs and create more bugs in the process, which another developers after them will fix. And when company this big is going by this approach, and we can see that they are thriving. What do you think about it?
Well,
it depends what kind of software you do. Yes, in Facebook you can have bugs, but in an ERP system like NetSuite you can't.
I don't know if you can have bugs when you throw, I don't know, like $10,000 into the marketing campaign on Facebook. I don't think you can have bugs. Of course you can have bugs, and
yeah, right.
They
Depends on what kind
bugs.
of bugs.
Okay.
Well, then we of course have bugs and tons of them, but usually small things, like you can't have accounting wrong, and we are trying to be really careful about the sensitive parts.
Okay, thank you.
So I think at least in NetSuite, it really depends on the situation, because the development takes much longer than we would want it, because it's quite, sometimes we are working with a very old legacy code. Sometimes we are working with new code. So it takes us some time to find out how it's working right now, because that piece of code was written by someone 10 years ago.
You should have tests for that, no?
Yeah, well, we didn't have tests from the beginning, so we are catching up. So in NetSuite, I think it's half tests and development code. But I think sometimes when I work on personal projects, I think it's even like more tests than the code. So it all depends on the situation.
The important thing is that tests are much simpler code usually than the productive code. It's psychometric complexity is 0 or 1. It's very simple. So this is also the reason why the test could serve as a documentation.
Yeah.
Because everybody says that the truth is in the code, and the code itself is a documentation. But the ugly truth about programming is that it's simpler to write than to read the code. So in tests, the truth is much simpler and much easier readable than in the productive code. Could you guess how many times a typical line of code is read after it's written?
I think that I will read it like half a year ago, and then maybe my mother when I show it to her.
It could be in your personal projects, but the industry average in the software industry as a whole is 300 times. So every single code is read by somebody, usually by somebody else, 300 times. So it's extremely important to have it safe for the future.
Okay. Was the time? Can we have some more questions?
Yeah.
Okay, so hit me. So if you don't, I'd like to thank you for your attention and good luck and fun with your Swimboat event. And we'll see if TDD or not TDD will win. Thank you.
Okay, so we'll have a like 5-minute break, and then, or 8-minute break, and we'll start at a half.